I love movie night with you.
Me too, Savannah.
I just wish we could maximize the area of my laptop so it would fit in perfectly into this oval sink we have.
Do you even know how to do that?
You bet I do. Do you want me to show you how? Come on. So here we'll maximize the area of the laptop, which is the rectangle inscribed by the sink, which is defined by x squared over 4 plus y squared equals 36. Our goal is to maximize the area, so we find the area by deriving it from a rectangle area equation, which is area equals length times width. And to keep it non-negative, we will do area equals 4 times x times y. X and y are shown in the graph onto the right, and our domain will be from 0 to 12. The constraint is defined by the oval equation, which is from the sink, x squared over 4 plus y squared equals 36. It can be rewritten as x squared plus 4y squared equals 144. From that, if you solve for y, you'll end up with square root of 36 minus x squared over 4, which is also y equals 1/2 times the square root of 144 minus x squared. We will plug in that y value that we just found into the area equation, which was 4xy, and we want all x variables. So we plug it in and we get area of x is equal to 2x times the square root of 144 minus x squared. And there we want to take the derivative. So as we go through, the derivative of the area is equal to 2 times 144 minus 2x squared over the square root of 144 minus x squared. From there, we want to set the derivative equal to 0 and plug in to find the x value. So from there, we only need to multiply or to plug in from the numerator. And so we end up with x equals the square root of 72, which is also equal to 6 times square root of 2. And then now we want to also plug in our endpoints and our x value to make sure that is the max area that we have found. So if we plug in 0 into the original equation that we have of the x area is equal to 2x times the square root of 144 minus x squared. We end up with 0 for plugging in 0. For plugging in the square root of 72, we end up with 144. And if we plug in the 12, we end up with 0 as well. So we know for sure that this x value produces the max area. And now we want to go back to the constraint, which was y equals 1/2 times the square root of 144 minus x squared. And we will use that, the x value that we just found, and plug it back into the constraint so that we get the y value, which is 3 times square root of 2. And so now we can find the dimensions. So the x value is equal to 6 times root 2, and the y value is 3 times root 2. And if we want to find like the whole length, it would be 12 times root 2, and the width would be 6 times root 2.
That was sure a lot of fun. Thanks for showing me how to do that math.
Anytime there, friend. Optimization rocks.